session. My name is Debu Panda. I'm a senior manager of product management with Amazon Redshift. And with me, I have Ron Colley, who is the principal product manager for IAM Identity Center, and Camille Taylor. She is a product manager in Amazon QuickSight team. Today, we are going to present you how you can simplify and improve your access policy for all your analytics need, that whether you are using Redshift, whether you are using EMR, QuickSight, all the different analytics services that you are using, and how you can improve your single sign-on capability, how you can use IAM Identity Center to improve your authorization and auditing capabilities. I was a DBA, Oracle DBA, about 20 years back during my initial days. And at that time, I was a part of the data warehousing team. And at that time, there are only very few data warehousing users who are using for, primarily monthly dashboard or, any kind of reporting needs they had. But AWS really democratized the access of data and analytics with many services that we have. And if you are a DBA or a data admin or security DBA, then you always think about how to provide right access, not only the access, but the right access to the data to the right users. You have, earlier only, there are only some reporting users or power users who are accessing, your data warehouse or analytics, platform. But nowadays, you have a lot of different kind of users. Some organizations have hundreds or thousands of users, business users, who access their data. There are marketing analysts, financial analysts who needs access to their, analytics platform. And in order to manage, if you're a DBA or a data admin, what you need to think about is that, okay, these are the different persona or different kind of roles that you have that you want to create in the database. And then each of these roles might require different kind of access to the data. Like, for example, here, 3 different roles. Assume that there are, purple role, there is a pink role, and there's a yellow role. And these different users will need different kind of permissions. And when you are providing access to your data to thousands or hundreds of users, you probably do not want to create different users for this in your database systems for this user. What you generally do is that integrate your single sign-on system, whatever you have, with your analytics platform like Amazon Redshift or Athena or any other, or QuickSight is, let's say Azure or BI tool. So what then you do is that, when you integrate your single sign-on system with the analytics systems in AWS, you have to use IAM. And each of this role, you need to think about IAM role. And IAM role is for a specific group of people that they need to assume, and they log in and perform their action, whatever they need to do. So with that, what we hear from customers, there are several challenges that we hear. When you are using Redshift, many customers use, for example, local database user. And sometimes if they are using QuickSight, they might not use single sign-on again, and that might use QuickSight users. So what happens is there is a lot of proliferation of different identity or different users, and what happens is that users forget their password. At the right time, whenever they are about to generate their report, they forget their password, and then need to contact the admin or IT system, IT admin to reset their password. Then there are power users. Power users like, for example, data engineers, or there might be LOB users in a specific LOB admin department what they do is basically they have more access to the data rather than an individual marketing analyst. So, and sometimes what happens is that when you're using AWS, you have to assume a role, and then one time you can assume one role, and that will give access to the specific set of data. So when if you want to see all data together, then it becomes a challenge. Then the database admin, for example, who is managing their access to the data, and they are using, let's say, a data lake, and they have the data is based out of S3, as like for example a spectrum table or a table in Athena, and what they want is that they want to grant access to that table based on an IDP group or IDP user, which is generally is very, very difficult because we do not support easily right now, and they have to grant access to an IAM role. Then when you define all the permissions as a data admin, you have created different database roles, and you are now integrating with IDP or your identity provider, and then now you have to think about how to map this this IDP group to this database role, because all the permissions are in IAM, and all these things happens through an IAM role by either adding a principal tag or defining in the policy. So that becomes a little bit more complicated for users. You define all your policies, everything works fine, but the auditors have the challenges, because when you assume an IAM role, generally the user is lost, unless you are fast or federated authentication service. So what happens is that they will logs in, try to run a query, and the query goes to, let's say, S3 or Amazon Redshift Spectrum. Then I have to assume an IAM role. When I assume an IAM role, my username is lost, and if you look at the logging, this actual IAM role is logged. So you cannot do end-to-end auditing. So this is not a problem in just in AWS, but majority of the cloud providers. So what customers, like we talk to many customers like you, and what we heard from them is that they want seamless access to their data based on their user identity. If it is Debu, give me access to Debu, whether he is running a query from Amazon Redshift Query Editor, or he is running a query from QuickSight or Tableau. And they want the same user to have access to either a dashboard or a data set or stories, or if they are using generative BI or generative AI in some tools. So they want the same user to have same access of data coming from whatever the tools they are coming from. Okay. We introduced a new feature yesterday, thankfully, that help you centralize the management of access of all the different kind of applications with many services. So we are going to focus on with Amazon Redshift and QuickSight in this session. But what it does is that basically it centralizes single sign-on experience from Amazon QuickSight and Query Editor to Redshift, and also allow you to enforce the permissions based on the user group or user identity. So if Debu is part of two different group, marketing and analyst, then which is defined in your identity provider, like whether it is Entra ID or Azure ID, or or it is Okta or OneLogin, wherever you've defined. Whenever I am running any queries in any of this tool, my user ID will be used to give me access. And with this, we are providing you, the choice of whatever the IDP you are using. Like it's not that you have to use only IAM Identity Center. You can use as other Okta, OneLogin, Jump Cloud, Google Workspace, whatever you are using. And not only we provide you, the access based on your user identity, what we are also going to do is that user identity will flow across system. So for example, if you are running a query from QuickSight, and QuickSight your logging is as Debu, you'll be able to create a dashboard that allows you to propagate that identity, Debu's identity, and to Redshift for granting permissions. So you can have all your RLS, CLS policies enforced in Redshift, and not only that, but let's say the query basically goes to S3, and you have enforced using lake formation. Then what happens is that that identity will also go to lake formation. So you will have end-to-end auditing between these services. So the feature that we introduced is called trusted identity propagation. So as a user, this is the feature that we announced yesterday. As a user, whenever you log in using whether you're the third-party identity provider or using IAM Identity Center, whether you are using Redshift Query Editor or QuickSight or Amazon EMR, for example, Studio, then you get a token from your identity provider, and that token is passed, or the identity is propagated to other downstream services, which is in the back end, like for example, Amazon Redshift or lake formation. And lake formation and Athena is coming very soon. And also we have support in Amazon S3 that we are going to talk a little bit more. And as we've been discussing, the identity passes between different services. So, you can look at CloudTrail logs, and you'll see Debu's identity everywhere. When you go to Redshift, audit logs, you'll see Debu's name there. So the identity is passed, is there logged everywhere, so that now you'll be able to meet your auditability and the compliance requirement that you might have. So again, this is more detailed on the trusted identity propagation that we announced yesterday. So whether you are using QuickSight or Query Editor, and then any tool which integrates with Identity Center with their OAuth 2 mechanism, they will be able to also use this with Redshift or any other data services that we have here. And as I earlier explained, all your Amazon Redshift, row level, column level data masking policy will be enforced in the Amazon Redshift table right now, and then lake formation support is coming very soon. And as you can see here, you will be able to simplify your authentication mechanism. You'll be able to simplify your authorization mechanism. You'll be able to meet your auditability requirement. And to discuss more about IAM Identity Center, what it is, and how does the identity propagation works, I want to hand over to Ron Colley. Ron?
Thank you, Debu. All right, I'm Ron Colley. I'm Principal Product Manager on Identity Center. How many people are familiar with Identity Center? Few, okay. So what I want to do today is I want to give you a little bit of background on what Identity Center is and the role that it plays in bringing together this identity propagation. Imagine that a few of you are familiar with IAM users and IAM groups. Yes? Okay, so that's the way that Amazon started out. We had IAM users and IAM groups. IAM users are really just a credential. They're not really a user. They're a credential. It could be a machine, it could be a person. We have groups as well. And you create your policies and associate it with that IAM principal, and a user would sign in with that credential, and they would be able to access things based upon the policies that you put into that IAM credential. Now, a lot of customers had identity providers, and they wanted their people to be able to sign in with the passwords and the usernames that they had when they accessed their other applications. So we created a way to federate an identity provider with AWS accounts. We'll call that IAM Federation. And what would happen is a user would sign into their identity provider. The identity provider would return back an assertion. And in the assertion, it would list the roles that that person has access to in AWS. So the user would then go into the console. They would assume a role. They would get back this role, and then they would go into the console of other services, and then they would access those services. And that's how many people are doing things that way today? Quite a few of you, okay? All right. Well, back in about 2017, we launched a new product. It was called AWS Single Sign-On. And today it's known as IAM Identity Center. And at the time, the problem we were trying to solve was to simplify account access management for people who had Active Directory. And we created a capability that we call multi-account permissions. And what it does is it allows you to create a role template that we call a permission set. And then when you assign that a person or a group to that template, then we generate a role in the target account and we manage the access into the account. So it takes away some of the heavy lifting of provisioning roles. And like I said, we did this initially for people that had Active Directory domain service. This is the Active Directory that runs on Windows servers. And we were trying to help people who were using Active Directory Federation service, which was a bit hard to use for doing federation types of things. And because we were trying to solve it for them, we also added in a capability of giving SAML 2.0 access into customer managed applications. So you could get into things like Box or Salesforce. Now, what happened over time is customers said, well, we like the idea of multi-account permissions. We don't use Active Directory. We need a way of doing this. And so we added in the ability to create users and groups inside of Identity Center. And then later we had people say, well, we really like the multi-account permissions model. We're using our identity provider today. We'd really like to get out of provisioning all these roles. And so we added the capability in 2019 of connecting up Azure AD, which is now Entra ID. And in that model, what we do is we synchronize the users that are in the IDP into Identity Center. And it gives us one place in AWS for the users, and they're usable across all of your accounts and applications. And then when someone goes to sign into one of those services or applications in AWS, we redirect the authentication back to the identity provider or to whatever identity source that you've chosen. Now, shortly after, as we did that, we also added in a new capability. We recognized that we were getting more and more into applications in AWS, and applications needed access to user and group information to be useful, particularly in collaborative use cases. So what we said is, hey, let's create a platform that lets AWS managed applications be able to use Identity Center for authentication and also as a directory. It wasn't long after we announced the Entra that we introduced others, and now we support this list of different IDPs that you can connect and bring in the users and use them in these use cases. Now, a lot of you, the people who have heard about Identity Center before, did you think of it as account access management as primary? Yeah, mostly? So it turns out that we do a lot more than that now, and in a minute I'm going to show you how many applications we actually have operating today. But before I get into that, I wanted to talk about why do we do this model. Well, if you connect your identity source to Identity Center in one place, and particularly if you're using an IDP, the first thing is you only have one certificate to rotate for federation. If you're federating to every single one of your accounts, you might have hundreds or thousands of accounts. We have customers with well over 3,000 accounts today. And you have to take care of those certificates and make sure you manage that connection. If you're connecting to multiple applications and those applications need to understand the users and the groups, then you have one place of synchronizing those users and groups into AWS versus synchronizing to every single application. Now, we all know that synchronization is not perfect, and so there's always entropy involved, and then you have to do things like full syncs and things like that to correct it. But you could imagine if you had federated to hundreds of applications and each one was doing its own sync, then you'd have all the applications with different versions of what is going on in the directory. So having one place of sync helps to get more uniformity. Another issue is that this gives us a single point of authentication into AWS. There's only one code path that we have to solidify at AWS to give a secure connection in. And if some new log4j type of event happened in the identity space, we only have one place to fix it. I don't know how many remember back to log4j and how many services had to just stop doing everything. And it took weeks and weeks for hundreds of teams to go off and build solutions to correct log4j. This takes that out of the application space and puts it into one place because they're just using some APIs to call this code path. Now, what that does is it allows all of the applications to have a consistent view of the users and the groups across all the applications. So now we can start having applications collaborate and pass identity back and forth, and they can refer to the same person. It also opens the door for making it easier to do resource management. So a resource owner has this resource. They want to be able to give access. And the way we think about that is giving access to people and to groups. So you can have a really direct relationship between the groups that are in the directory in Identity Center and the resources that are being managed by a service. And what this makes it easier for the auditor to do, an auditor can go in and look at the policies or the access rules that are inside for that resource, and they can directly connect that this user or this group has access to this resource. And this is a little bit different than if you take a look at an IDP model. In an IDP model, the resource owner has the resource. They have to create application roles. Now, I use the same hat we use for IAM roles. That's not what this is. This is an application role. And in the cloud, what we know is this application role has access to these resources. But there's no way you can tell who the people are that can access those resources because that information doesn't exist in that resource provider. To do that, you have to go over to the identity provider, and the identity provider admin has to assign users and groups to this abstraction, which is an application role, and they assign it there. And if you go over to the IDP side, you can tell who has access to a role, but you can't tell what resource they get to. And so the auditor has to span both of these systems and bring together data from the IDP and from the cloud to try and figure out who can access what. Now, another benefit of the model that we have is innovation. So when we add innovations into Identity Center, those innovations are available for AWS applications to use, and they can count on those having the consistent APIs that they can work with and that will work with the identity source that you as a customer have. And so they don't have to worry about nuanced differences between different implementations of IDPs. And a good example of that we're going to cover today is going to be trusted identity propagation. Now, I mentioned a minute ago, you've maybe thought about Identity Center as a way of accessing accounts in AWS. Well, we have over 20 applications that have integrated with Identity Center because of some of these benefits and being able to they can get rid of the effort of trying to do sign-in and directory actions on their own. And today, we're here to talk about a new set of integrations from QuickSight, Redshift, EMR Studio, Lake Formation, S3 Access Grants, and Amazon EMR on EC2. And coming very soon, you'll see integrations from Athena as well for Athena SQL. And before we dive into that, I'm going to talk just a little bit about the models of how you deploy Identity Center. And a lot of people come and say, well, gosh, I can't use Identity Center. I've already got all of my IAM stuff in place. Well, you can choose to use it for a multi-account permissions if you want. And that's great. It's a really great solution for that. But you could also choose to just deploy it for the applications purposes. So you don't have to use the multi-account permissions to use Identity Center. You can just use it for applications. But if you want to, you can do it for both use cases. So the key point here is that it has the flexibility that you need. And if you do decide that you want to use it for multi-account permissions, it coexists with what you're doing already. So you won't break anything. It has its own code path, its own federation path. And so you could play with the multi-account permissions and see if that works out well for you. But in the meantime, you can use it for the application use cases. Now, from a deployment pattern perspective, there's two dominant patterns. There's actually three patterns, but I'm only going to talk about two today. One is that people have an IDP, like Entra or Okta or Ping or OneLogin or CyberArk or whatever that might be. And they connect their OIDC applications and SAML applications to their IDP. They might be using Active Directory domain services behind the scenes as the source of truth for the users and the groups, and those are synchronized into the IDP. And then they'll connect their IDP up to Identity Center, and using the SCIM protocol, they synchronize the users, and using the SAML protocol, Identity Center will authenticate people into the applications or into their accounts and be redirecting that authentication back to the IDP. So that's one of the top patterns that we have. We still have a lot of customers that aren't using IDPs, and they are using Identity Center as their user and group management system, and then they connect all those use cases. We still do have a number of people that are using Active Directory and connecting it directly to Identity Center. It looks like the pattern on the right. It's just that that would be Active Directory connected there. Now, with that, I'm going to turn it over here. We want to take a look at some. Let me back up. Here we go. The trusted identity propagation builds on top of Identity Center to deliver this easier way to do user-based data access control and auditing with a single sign-on experience. And we've got several different use cases. We're going to be talking about Amazon Redshift Query Editor and QuickSight today, and I'm going to be turning over this to Camille in just a second. We've got some other use cases involving S3 access grants for accessing data in S3 based upon users and groups. And we also have the EMR accessing data in lake formation. And then coming very soon, we've got Redshift Spectrum using lake formation for access. And we also have EMR Studio with accessing Athena SQL using lake formation to manage access to data. So that's kind of the patterns that we're going to be covering. I'm going to turn it over now to Camille, and she's going to do a demo of what this really means.
All right, so let's look at how all of this works in practice. So here I'm logged in as Jane, and I'm going to access QuickSight using Identity Center. So I'm logging in as Jane, putting in my credentials. And Jane is part of the analytics group in her organization, and she has access to all the stored sales data. So she goes into QuickSight, and she wants to access that data and create a dashboard. So she's going to go and connect to Redshift. She's going to put in a name for the data source, select the cluster, select the database name, and then she's going to select single sign-on and create her data source. And then once that's done, she's going to select a schema she's got access to, as well as a table. She's going to select the store sales table here. And then she's going to take a quick look at that data set, make sure it looks good. That is the data she was looking for. And she's going to go and publish that data set. Now she's going to go work on her analysis, and eventually she's going to publish a dashboard that she wants to share with the Store 1 group, which Paulo's a member of. So she's going to go and share that dashboard with the Store 1 group from Identity Center. And there we go. That's shared. So Paulo can now access the dashboard in QuickSight based on his group membership. And as we can see here, there are multiple colors for the different store IDs that Jane is allowed to see based on her permissions in Redshift. Now Paulo's going to log in to the same dashboard, and we're going to see what his permissions look like. So he signs in to QuickSight. Puts in his password. If he was already authenticated before, this would just be a seamless single sign-on, and he wouldn't have to put his credentials. And then he goes into his dashboards, opens it up, and as you can see here, he can only see store ID 1 data because he's got row-level security applied in Redshift that's seamlessly propagating to QuickSight. Now we're going to go take a look at the configuration in the Redshift console to see how this all ties together. So we're going to first take a look at the Identity Center integration for Redshift. So there's an application here in Redshift for Identity Center that the cluster is part of. And here you can see the different groups that have access to this application in Redshift. And the analytics group that Jane is a part of and the Store 1 group that Paulo is a part of both have access to this application. Now we're going to go take a look at the row-level security rules that were applied in Redshift by Jane. So she created roles that have the same names as the groups in the identity provider, in IAM Identity Center in this case. She defines a role-level security rule that restricts access to data to store ID 1. And then she applies those role-level security rules to the groups in Identity Center. And as well to the right tables. And then finally, she activates those row-level security rules. So once all of that is done, data is restricted based on row-level and column security in this clusters on the tables that were specified. Now we're going to take another hop back to IAM Identity Center and just go take a look at the users and groups. So if you take a look at that first line again, we've got store 1 in the analytics group. So we're going to go take a look at the group memberships of Jane and Paulo. So we're logging into the IAM Identity Center console now. And we're going to go check out the users. These could be users synced from the identity provider. We're going to go and check Paulo's group membership. So he's part of store 1 group. And Jane's part of the analytics group, which had access to all the store ID data, to all the store IDs, because she's part of the analytics group, works in the corporate headquarters, and can see all the data. So that is how that all ties end to end and the different components that interact together between QuickSight, Redshift, and IAM Identity Center when you have trusted identity propagation enabled across these services. Now, I've got another quick demo. We're going to access data in Redshift Query Editor v2. So this time we've got Ethan, and he wants to use Query Editor to run a query. So he's logging into Identity Center, and this time Okta's configured as his identity provider because that's the identity provider that his organization uses. So when he logs into Identity Center, he's putting in his Okta credentials. If he was already logged into Okta, this would seamlessly sign in without putting in a password. We can see we've got Ethan logged in. He's going to go to the Redshift console. Here he's using a permission set in IAM Identity Center, but he could access the Redshift console any way that his organization enables that. Okay, so once he's in the query editor, he's going to authenticate using his IAM Identity Center user. So he's selecting IAM Identity Center on the Redshift cluster and clicks on Continue. All right, and now we're just going to do a quick check to see that Ethan is really logged in as an IAM Identity Center user. So if he selects his current user, he can see that he's an Identity Center user of Ethan. That is his current access. And then he's going to start querying data. So he's got access to one table here that he wants to select. So he's going to the schema and going to select the table. So here he's allowed to see store sales data, so he can view the results in the query. It's successful. And then he's going to try to query another table here, the revenue table. And based on, in Identity Center, in any of his groups, he doesn't have access to that table. So he gets a permissions denied, which is what we want here. He's not allowed to see that data. All right, so that was a quick demo of how this all works in Redshift and QuickSight. And Ron's going to give a bit of a deep dive now on how trusted identity propagation works.
Thank you. All right, so when we built this, we based the model of identity propagation on the OAuth 2.0 model. So in OAuth, you have an authorization server, and there are applications that are connected to it, and the applications all trust the authentication server. So a user goes to an application, a requesting application, and that requesting application completes an authentication process. As part of that, they get an OAuth token back. And the requesting application wants to talk to some downstream service. So maybe this is QuickSight going to Redshift. And the requesting application passes the token along to the receiving application. The receiving application can introspect the token. It might be an opaque token, in which case it needs to go back to the authorization server to get the introspection completed, or it might be a transparent token. But regardless, the receiving application can identify who the user is, which is the subject. They identify what application the token was generated for, what the intent was, and that's the audience, which says this token was generated for the requesting application to talk to XYZ, which is the receiving application. And it may contain some scopes as well that define what are the types of operations that the requesting application needs to do in the receiving application. the receiving application can then make a determination if it wants to allow that access based on who the user is, what their group membership might be, and the scopes that are requested. Now, in a typical OAuth world, if you have a pure OAuth flow, a user goes to some entry point application, they sign in, they get the token, and then the subsequent applications are just propagating the user identity down to other services. So that's the way it would work in an OAuth world. But how many people have OAuth services that are running natively in AWS? Probably not a lot. Everything's based on SigV4. So what we did is we created a way to bring together OAuth and SigV4. So what can happen is that you started an application that obtained an OAuth token. So they went through some single sign-on process, maybe it's QuickSight, something else. They get this token. The application wants to call a SigV4 service, and it wants to pass along that identity. So we created a new mechanism where the application can make a request, extract the user identity out of the token, and inject it into an IAM role. Now, this is a new way of injecting identity in an immutable fashion into an IAM role. And so now this identity gets propagated along with the use of those roles. So if I have a SigV4 application that now knows how to use this identity from the IAM role, it can actually extract the user identity out. It can make calls to Identity Center to find out about group membership, and it can then make authorization choices based upon the user of that role. Now, if that SigV4 service wants to propagate identity down to another SigV4 service that has not been updated to understand about users, that's okay, because what it can do is it can pass along a role with the identity injected, and the downstream service will just do normal IAM role processing based upon the permissions that are in the role. But what happens here is that CloudTrail is aware that some action was taken by this IAM role. And it looks at the role, and it can tell that there's an identity in there. And so CloudTrail will extract the user's identity, and it will log the action that was taken along with the user's identity. So now, whether you're using a identity-aware SigV4 application, an OAuth-aware application, or a SigV4 application that doesn't understand identity but gets a role with identity in it, the user identity now gets logged along with the action. So this really changes the game for how you deal with auditing across AWS. So let's take a look and see how this works in a couple of use cases, what we just saw a minute ago. So a user goes to something like QuickSight or Redshift query editor. And in that process, there's an authentication that gets triggered. In the case of QuickSight, it happened because QuickSight is a web application that knows how to do federated authentication. In the case of the query editor, that was a console-based application. And when you get into the console in AWS, you assume a role, and then you go into the application you want to go into, and what the application knows about is a role. So when we first entered query editor in that demo, query editor didn't know who the user was. It only knew that there was a role that authorized them to access the query editor. And so the query editor has this new option, which Camille showed you, which said, I want to use IAM Identity Center to sign in. And so that created a second sign-in process. Now, the sign-in flow would take you to your IDP if you're using an IDP. Otherwise, you see an AWS sign-in screen if you're using Identity Center users or you've connected Active Directory. Now, Identity Center then returns back an OAuth token. So we now have an OAuth authorization server inside of Identity Center that returned back a token that contained the user information. And the user that's there is a user that's in the identity store of Identity Center. So now those applications make a downstream call to Redshift and pass along that OAuth token. Redshift can then extract out the user's identity from the token. It can make an authorization decision based upon their group membership and give them access. So that's what we saw today in the demo. Now, we have some, I said coming soon, we have Redshift Spectrum with lake formation. So this is a coming soon situation. And I'll show you how that will work here. So the first part works just the same. The user goes to the application, they authenticate, they get a token back, they pass the token to Redshift Spectrum. Redshift Spectrum is using lake formation to access data. And lake formation is a SigV4 service. So what we did is we made lake formation identity aware, so it knows how to extract a user out of a role. So Redshift goes to the secure token service. It passes along the OAuth token that it got, and STS will send back a role credential that has the identity injected into the role. Redshift then passes that role along to Lake Formation. Lake Formation extracts the user's identity out of the role. It determines what that user can access, and it generates a brand new role, a red role here, and injects the same user identity into that role. It hands that role back to Redshift Spectrum. Redshift Spectrum can then go to S3 with that role. S3 doesn't know about the identity. So it just processes based upon the permissions that were in the role that was handed back to Redshift from Lake Formation, and the user gets access. And during that process, along all these steps, we see the user who signed in being logged with all the actions along the way. Make sense? Okay. All right. Now, another coming soon is we have applications that are outside of AWS that want to authenticate maybe directly with an identity provider. So maybe it's an application that you've written yourself, or maybe one that you've purchased from somebody else. In that case, the user goes to the application. The application is authenticating against your identity provider directly, not Identity Center. So it gets a token back from that identity system. It passes that token in through the Redshift driver, which ends up at Redshift. Redshift is configured to accept tokens from the external system. And that external system is first registered with Identity Center. So there's that linkage between Identity Center and the IDP. And that linkage, in this case, is the OIDC discovery endpoint of the OAuth server. And that allows Identity Center to receive that external token from Redshift. It can go off and get the keys to verify the signature on the JOT that it received. It can then do a lookup in Identity Center to find the corresponding user, and it generates a brand new token that is an Identity Center token for the Identity Center user that's been synchronized in. At that point, Redshift can exchange that token for an IAM role that's injected with identity. They go to Lake Formation with that. Lake Formation extracts out the user's identity, passes back the new role with the identity, and Redshift goes to S3, and the user's logged through the whole process. So this is going to be a coming soon use case as well. So today, we're really super excited about the first steps that we're taking here. We've done a lot to get this to come out, and we've got more to build on, and we're really looking forward to those additional use cases. So at this point, I'm going to turn it back over to Camille, and she's going to go through some other use cases that we've just enabled.
All right. Anyone here use Amazon EMR for analytics? Yeah? Few? Okay. Good amount. Nice. So we're enabling trusted identity propagation with Amazon EMR through two flows, one through Lake Formation and one through Amazon S3 access grants. And as Ron just described, it's the same kind of mechanism where the identity gets locked through CloudTrail. So the way this works with Amazon S3 access grants, let's say you have a user that submits a Spark job with Amazon EMR through EMRFS. EMRFS calls Amazon S3, and credentials are returned based on the user running the job to get used in EMR to run the job. So you can enforce granular access to buckets or bucket prefixes based on user's identity or group membership from your identity provider through IAM Identity Center. Second use case is if you want to apply fine-grained access control for Amazon EMR jobs, you can do that with Lake Formation. So you can enforce column and row level security with Lake Formation on data that's in Amazon S3, and that's supported with Hudi, Iceberg, and Delta Lake. And then finally, through EMR Studio, support is coming soon for Amazon Athena. So same thing, if you're accessing Amazon EMR Studio to query data on Athena, data secured in Lake Formation. So when users are querying data on Athena through Amazon EMR Studio, that data is secured with trusted identity propagation. We've got a bunch of sessions this week that goes into detail on these different use cases. I'm giving a chalk talk tomorrow on QuickSight and Redshift trusted identity propagation. We've got JP Chase also in that chalk talk. So if you want to chat more about your use cases and how this works, please come join us. There's also several sessions on S3 access grants and EMR Studio. So please join us in those. And then to summarize what we discussed today, so we launched this year integration with IAM Identity Center for 6 analytics services. We've got Amazon QuickSight, Amazon Redshift, AWS Lake Formation, Amazon EMR, Amazon Athena, as well as S3 access grants. And we've enabled a bunch of use cases with trusted identity propagation across those services. So we're excited to see how you adopt this feature. And thanks for coming to this launch session that we just launched this yesterday, by the way. So yeah, thanks for coming. Enjoy your first evening at reInvent and enjoy the rest of the week.